I am discussing the static indeterminacy of the truss. Now, for static indeterminacy, it is quite easier than the static indeterminacy of beam. I will tell you how. Now, for this, let us revise a bit beam first. So, what in beam we learnt that there are three type of forces mainly, which are axial, shear and bending. So, in beam we have three unknown in one member. So, we can say total number of unknown is 3m. Then we have R reactions. So, total unknown becomes 3m plus R unknown. And equation available at every joint is 3, which is summation h equal to 0, summation v equal to 0 and summation m equal to 0 for 2 dimension. Okay, so I am discussing 2 dimension here. So, what is the equation for static indeterminacy in a beam? 3m plus r minus 3j. Now, if this is greater than 0, then structure is stable and indeterminate. If it is equal to 0, then structure is stable and determinate. And if it is less than 0, then structure is unstable. In the same line, if we discuss truss, then I have only axial member. Okay, so how many unknowns I have? The unknowns are m. Each member will have one unknown, which is the axial force. So, how many unknowns? M. Then reactions are unknown in truss also. So, R is the reaction. Clear? And what is the known equation? Known equation is 2j. Since all the joints are pin jointed, so we get summation h equal to 0 and summation m equal to 0 at each joint. Clear? So, what is the static indeterminacy? Static indeterminacy is m plus r minus 2j. Now, if this is greater than 0, then structure is stable and indeterminate. If it is equal to 0, then structure is stable, means truss is stable. And if it is less than 0, then truss is unstable. It is so simple. The another part in this is to understand the stability. Now, other than the equation, you have to be alert for the stability, which I discussed in my first video of the truss analysis, that if truss is having rectangular part, then it will be unstable. Just see this truss. So, if you see in this truss, what is m? M is the number of members. So, members are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So, m is equal to 17. Now, how many are reactions? 2 reaction here and 1 reaction here. We will not have any fixed support in the truss because there is no moment. So, the supports will always be either hinge or roller. So, how much I will get here? R is equal to 3. Now, what is J? J is the number of joints. So, how many joints I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, I have 10. So, how much I get? I get m plus r minus 2j. So it is 17 plus 3 minus 20, which is 0. So this truss is statically determinate and indeterminacy is 0 and stable also. Now see the same truss with two cross bracings in the second and panel third. So if you calculate, M comes out to be 19, R is same 3 and J is same 10. So what I get? It is 19 plus 3 minus 2 into 10. So static indeterminacy is 2. Now see this truss. This is an important truss, friends. In this truss, you need not to calculate M plus R minus 2J. The reason is that this panel is not triangular but it is rectangular. So this truss is unstable. Clear? So you have to first see that all the trusses members, all the trusses panels are triangular in shape. If you see any irregular shape which is a rectangle, then you will say that the truss is unstable. Now come to the 3 dimension. The thing is very simple here. Again, what will happen? The total number of members is M, so unknown is M. Okay. Now reactions are R and equation available at each joint is 3. So what are the 3 equations? Summation H0, summation V0 and summation H0. Summation Z0. Now what is Z? Z is the perpendicular to your screen. So I have 3 equations for the trusses in 3 dimensions. So at each joint I will be having 3 equations available. So what is the static indeterminacy? So static indeterminacy for 3 dimension is M plus R minus 3J. If it is greater than 0, then truss is stable and indeterminate. If it is less than 0, then unstable. And if it is equal to 0, then stable and determinate. So friends, this is about the static indeterminacy of truss. Friends, if you want more questions on this topic and solutions of GATE and engineering services questions appeared in the previous year, then WhatsApp me and I will tell you the procedure. Thank you friends for watching this video. I hope you learned a lot of things. If you like this video, give a thumbs up and please write a comment for any suggestion which you want to give me. Also, you can WhatsApp me for any query or any doubt which you are facing while watching the video. Thank you. Enjoy civil engineering.